This is the radial velocity, this is the tangential velocity for a uniform flow plus a doublet. Uniform flow and doublet makes this a uniform flow across a cylinder plus a vortex of strength gamma. The strength of the doublet is mu. So we have seen minus gamma by 4 pi a mu infinity. The value of this decides the position of the stagnation point. We have seen two conditions. The stagnation points to be here and here, and this is how the streamline flows. These are the two stagnation points for this value lying between 0 and 1. When this value is equals to 1, we have seen the stagnation point over here. The third value, when this gamma by 4 pi a infinity is greater than 1. Here we will see that the streamlines will be like this, and this will be the stagnation point. So the stagnation point will be outside the cylinder, will not lie on the cylinder, but will be beyond the surface of the cylinder. So if you make ur equals to 0, you will have this cannot be 0, this has to be 0. So theta is equals to pi by 2 or 3 pi by 2. So the stagnation point has to lie on the y-axis, right, from the first equation. From the second portion, we have mu infinity to 1 plus a square by r square sine theta at pi by 2 or 3 pi by 2. This can be plus or minus 1, right, is equals to minus gamma by 2 pi r. From here we will have to find the value of r. So this will be rs. So we can, this will be a quadratic equation. So we have u infinity plus u infinity a square by r square is equals to plus or minus gamma by 2 pi r square. So we have r square u infinity plus a square u infinity equals to plus or minus gamma by 2 pi rs. So rs square u infinity plus or minus gamma by 2 pi rs equals to a square plus a square u infinity equals to 0. We have minus gamma by 2 pi plus minus root over of gamma by 2 pi whole square minus 4 into u infinity square a square 2 into u infinity square. So this will be r. Yes. We can see that this rs has to be positive. So this is positive only when this is positive. When is only when this, so this value is always less than this value. So this cannot be negative. So this cannot be positive. This has to be negative. And for this to be negative, this comes from this side. So this has to be positive. Okay. So for this to be positive, this has to be minus 1, which means sine theta has to be minus 1. So theta equals to 3 pi by 2. So it has to lie over here, not here. This is the distance rs, which is more than a. Again, let me tell you that this can be positive or negative. Okay, this cannot be more than this. So if this is negative, then rs is negative. If this is positive, then this, the magnitude of this is more. So even if this is positive, this entire value cannot be positive. So this cannot be negative. This has to be positive. If this is positive, this has to be negative. For this to be negative, this has to be positive. This has to be positive. For this to be positive, here has to be a minus 1. Minus 1 is only possible when sin theta is 3 pi by 2. So the stagnation point is here. Okay.